Working with numbers in the Python 3 console using Runpython. This is a tutorial for complete Python programming beginners with no prerequisites at all. The only software you need is a web browser, so you can visit the online Python 3 interpreter at runpython.org. Just type runpython.org in your browser address or URL window and get the screen that you see right now. Once you get this, go click on the link in the lower right-hand corner that says Runpython console. And by the way, you can run this tutorial in probably just about any other Python console window. So if you have real Python installed, you can go ahead and follow along there as well. The Python console gives you a direct interactive access to the Python language, and the console is a great place to test out short snippets of code or investigate built-in Python behavior without actually creating full programs. We're going to start by typing some numbers. Type a number, press enter or return when you're done after each number. We're going to type some with and without decimal points and see what happens. So 3, 3.0, 3.1, big numbers with decimals. Now, what's going on when we type numbers into the Python console is that Python is actually creating an object in the computer's memory. So you type, say, 3 up here, and Python looks at what you type and says that represents the number 3. It creates some space in the computer's memory and generates a representation of the number 3 using binary and stores it in the computer's memory temporarily. Python then turns around and grabs that value and returns it to you as sort of an interpreted value. And since this is very simple, you type 3, it says, oh, this is number 3. It gives you 3 back in a human readable form. We're going to see some examples later on where what you get back doesn't necessarily match what you think you should get back. The other thing we can do with these numbers is we can save them temporarily. We can do that like this. There's some examples. And I can do it again, like with a different number. So a equals 1 before, and then I say a equals 2. That's cool. And I should add that you can use spaces between the things you're typing. I mean, obviously, this name over here, num77, should be all connected, no spaces in between. But then I have the equals, put some spaces in there, and some more spaces after it. Totally cool. The other thing you might notice is that when we're typing these statements with a name or a letter, followed by the equal sign, followed by a number, and when I press the enter or the return key at the end of each line, it's not giving me anything back. It's just accepting it and doing something with it. If we want to see what Python has done, we can type one of those names again. For example, if I type A, it says 2. Now in this case, what Python is doing is it's grabbing that name that we typed and it's going and looking in its memory for an object that may have created earlier with the same name. The name points to or refers to an object in the computer's memory that has this numeric representation. You'll notice although we typed a equals 1 and a equals 2 later, the a is now associated with the last thing that we assigned to it. It's worth pointing out also that a line like this kind of looks familiar from a math point of view. In algebra, you might have an equation where the thing on the left equals the thing on the right, and you could use that to do something like solving for x. The equal sign in Python, and frankly most programming languages, it behaves differently. What we're really doing is saying the name on the left is now associated with or points to or refers to the object that was created on the right-hand side of the equal sign. So there's a direction to it. Object on the left points to value on the right. And we can't reverse that. For example, if I said 2 equals A, you're going to get what's called a syntax error. Python just looks at that and says, no, what you just said, that doesn't make any sense. I'm sorry. We can't assign, a syntax error says can't assign to literal. You can't assign a value to a number. A number can't refer to it can't be used as a name. So A is already a name, and we can't do this backwards. So A equals 2 is fine, but 2 equals A, not cool. The other thing I should point out, num77 that I defined or created earlier points to the value 66. The 77 in the name doesn't have any significance as far as the value of the variable. It's just another way of specifying a variable name. So variable names have to start with a letter. They can have multiple letters, and they can have numbers embedded in the name, but the name cannot begin with a number. Now, some other things that you can do. Well, yeah, so I've shown you, if we just type the name, we get the number back. So A is 2, P is 3.14159. We can also type expressions that are doing some kind of arithmetic. For example, A times B. So what's going on here is Python's evaluating the line A asterisk B. And in Python, like many programming languages, the asterisk means multiply. So Python goes and grabs the value in its memory that's associated with the name A, which is 2 in this case, goes into its memory and grabs the value or number associated with the name B, which is 23.5, and it uses the CPU to multiply those two numbers together, creates a third object in memory temporarily, and returns the representation of that in decimal, 47.0. Other things we can do. Division is the forward slash, so B 23.5 divided by A 2 is 11.75. Those sorts of things you can do in your calculator. We can do A divided by B, and we get a small decimal number. We can also do something kooky, B divide A. And in this case, what's happening is we're doing an integer division. We're finding out how many whole values, how many times A can go into B as a whole number, as an integer number. So A, which is refers to the value 2, can go into B, which is 23.5, only 11 times. So 11 times 2 is 22. B is 23.5. The difference is 1.5. You can't fit any more A's into B than that. You can type fairly elaborate expressions. You can use parentheses to group expressions. So things that are in parentheses will be evaluated first. You may remember the PEMDAS rule. Please excuse my dear Aunt Sally. So order of operations apply here. Whoops. I use P, not pi. And you can take expressions like that and assign them to variable names. Let's see, E equals. And so now E points to a number that's 0.5764, etc. And lastly, here's a piece of behavior that you might not expect. C plus D. Now, C is equal to 0.1, D is equal to 0.2, so C plus D should be 0.3. And Python says, no, not quite, it's almost that. What's going on in here is that under the hood in Python and most computer languages, the math that's being done is represented in binary. And the value 0.3 or 3/10 is a fraction that cannot be expressed exactly in binary. So it's getting as close as it can to 3/10 and then converting that into decimal and showing us the result. Now in Python, there is a data type that you can use for doing exact decimal calculations. It's not used by default. It's a little bit slower than this. But if you're doing, say, financial work where these sort of extraneous little bits and pieces of values are not appreciated, then you would use that instead. So the next thing that we're going to look at in the following tutorial is another type of data called strings, and we'll do that in a moment.